This is the lesson for Handout A, and so looking at our first problem we'll end up seeing talks about number properties. So you're going to see one of the number properties, and so you'll have to identify what it is, and so we'll go over a few of them here. This is called the commutative property when you switch the order. So you see how the 3 was on the right-hand side, but now it's on the left. So if you switch the 3 and the x, what we use there is the commutative property. Commutative property of addition is what that is. Here we are distributing 4 by x, 4 by negative 2 to get the 4x minus 8. So this is the distributive property. Now they could call it by its official name, distributive property of multiplication over addition. So that would be the official name. And even though there's subtraction in the problem, we could write this as an addition problem. You can write all subtraction as addition. This is the associative property. It's the associative property because you notice that the order didn't change. 3, 2, 1, 3, 2, 1. It's just the parentheses went around the 2 and the 1 here, but now they're around the 3 and the 2. So the associative property of addition. And the next one is the identity property. So identity property is when you multiply 1 by a number and you get the same number. So identity property of multiplication, or multiplicative identity is another way they say it. Negative 3 plus 3 equals 0. So when you have opposites equaling 0, this is called an inverse property. And this is specifically the inverse property of addition. Over here we have 5, 2, and 1. 5, 1, and 2. Notice that the parentheses are around the same numbers, the 2 and the 1 and the 2. So what changed is the 1 went in front of 2. So this is actually the commutative property. Commutative property of multiplication. Well, the next type of problem that we'll end up seeing is one that deals with fractional exponents. So the number on the bottom represents the number of roots. The number on top is the exponent, or the power that we'll raise it to. And so here we are looking for two numbers that multiply to make 4, but we're raising it to the first power. Times by 4 numbers that multiply to make 16, raised to the first power. Over here we'll multiply by 3 numbers that multiply to make 8, and we'll raise that to the first power. So this is 2 numbers that make 4, that multiply to make 4 are 2. Here this is 2 as well. 4 numbers that multiply to make 16 are 2. And another 2. 3 numbers that multiply to make 8 are 2. And they're all raised to the first power, so they don't change. And then you just multiply the numbers, and you get 8. Over here, even though there's parentheses, it's the same thing as just everything being multiplied. So it's a to the 4th, and then this a, b to the 6th, and then the b to the 9th. And so I just use the commutative property to move the numbers next to each other, and then I count up the number of a's. See, there are 4 a's and 1 a all being multiplied, so that makes 5 a's being multiplied, a to the 5th. And then count up the number of b's. You got 6 and 9 make 15 b's all being multiplied together. So a to the 5th, b to the 15th. Next one, notice how the 8's are exactly the same base, and so we can combine those together. So you count them up. You got 3 8's and 2 8's make 5 8's. And then we're raising this to the 4th power. So 4 groups of 8 to the 5th, and so that makes 8 to the 20th power. Over here, the reciprocal just means turn the fraction upside down. We do this when we multiply or divide fractions. We take the reciprocal. We also use the reciprocal when we're trying to solve an equation and canceling out a fraction as a coefficient. So just turn the fraction upside down. 2 over xy is the answer. Next one here, we're going to go ahead and move this 3 over first. So I'm subtracting 3 from all sides. So when I do that, I bring down this negative sign. So it's still negative, and then the absolute value of x plus 3 is greater than or equal to negative 11. So from this point, I'm going to get rid of this negative sign by dividing by negative 1. So when I do that, the signs will end up switching. So also, the inequality sign will change as well. So now it becomes x plus 3, still inside these absolute value bars, and this is now less than or equal to 11 because I had to turn that fraction, turn the fraction or the absolute value not the absolute value, but the inequality around when I divide by or multiply by a negative. So now I've got the absolute value set to a number. So what I'm going to do from this point is take that x plus 3, set it less than or equal to 11, but greater than or equal to negative 11. So from that point, you just have to move that 3 over. So I'm subtracting 3 from all sides. So when I do that, I end up with a negative 14 is less than or equal to x, which is less than or equal to 8. That would be our answer. And so this is an AND statement because the values of x are smaller than the positive, but bigger than the negative. So the next problem we're dealing with is one where you distribute the 2 over that difference to start with. So we've had 6x minus 16. This side, we're going to distribute the negative 2 over this difference. So now we have equals 5 minus 12 plus 10x. So from this point, we can go ahead and collect some like terms. So these two terms right here will combine. So now we have 6x minus 16 equals negative 7 plus 10x. So we go ahead and do one more operation here, a couple more actually. We're going to go ahead and add this 16 to all sides. And I'll subtract the 10x from all sides as well. So from this point, I got negative 4x equals, subtracting that, you end up with a positive 9. When I do the division, you end up with a x equals 9 over negative 4, or negative 9/4. So that would be our answer. Well, taking a look at our next one, similar. We've got to distribute the negative 2 over this difference, so we end up with a negative 2x plus 16 equals, you bring down the 3 and then you distribute the negative over that addition. So we end up with a negative 3x and a minus 2. So we're collecting some like terms here. We've got the 3 and the negative 2, those combined. So we now have negative 2x plus 16 equals, and we got 1 minus 3x. So 3 minus 2 just gives us that 1. And so from this point, you're just doing some opposite operations, taking 1 away from both sides, adding the 2x to both sides, and you've now got 15 equals negative x. So you just divide by negative 1, and we've got our answer. Negative 15 is what x is. Well, looking at our next one, we got a proportion. Whenever you have a proportion, you can solve by cross-multiplying. That's what we're going to do here. So we multiply the 2 over the 3x plus 1. On this side, we do the same thing. Multiply the 3 over that 5x minus 2. And so once we're doing this, we end up with a 6x plus 2 equals 15x minus 6. And so from that point, we can do some opposite operations to isolate the variables. So we'll go ahead and subtract that 6x from all sides. I'll add this 6 to both sides. And so now I've got 8 equals 9x. So I just divide by 9, and we get our answer. 8/9 is the value of x. Well, another problem here, and this rope problem that we've seen a few times. So the rope is cut into 3 pieces. So we don't know how long the different pieces are, but we know that we have piece number 1, 2, and 3. We also know that these pieces add up to make, let's see how long this rope is, 180 feet. So we know that all together they make 180 feet. So we know that the first piece, we don't know what the length is, we don't know the second piece, we don't know the third piece. So I'm going to use variables to represent them, but we know that they all add to make 180. So let's go ahead and look at what that says. It says the second piece, so y, is twice as long as the first piece. So y equals 2x. And then it says the third piece, so z, is 3 times as long as the first piece. So 3x. And so now we've got an expression with just x's. So now what we're going to do is we're going to go ahead and add those up. X plus 2x plus the 3x. And those all add to make the 180. And so when I go ahead and add this stuff up, 1x, 2x's, and 3x's make a total of 6x equals 180. And so when I do the division of dividing by 6, I end up with x as 30. And so we go ahead and take the look at what they're asking for, and they're saying, what is the longest piece? They want the longest one. So the longest one is 3x. So I have to do 3 times 30, and that makes 90. So 90 feet was the length of the longest piece. Last one here talks about how Ed bought 3 boxes of oranges and 1 box of pears. He spent $24. So that's a value equation. And so we've got 3 boxes of oranges. Let's call R equal to oranges. We don't know how much they cost. And let's call P the cost of the pears. So 1 box of pears. But the total cost is $24. So that's what we call a value equation. Well, the next sentence they say, the box of pears cost $3. Oh, this is another value equation. It's just a little different than we're used to saying. P equals 3. So now we know that. So let's go ahead and substitute 3 in for P, because they're going to ask for how much does a box of oranges cost. So let's go ahead and rewrite 3R plus 1 times by 3, which is 3, equals 24. And so we just go ahead and do some opposite operations. So I'm subtracting 3 from all sides. And so now we've got this 3R equals 21. Divide by 3, and we've got our answer. R is 7. So $7 is the cost of the box of oranges. Well, those are problems that are similar to homework that you'll see tonight on Handout A.